Good afternoon, all. This is Kamal Kishore Sharma, and Senior Lecturer, Department of Mechanical Engineering, IIMT College of Polytechnic. Today, I am discussing about basic property of engineering materials. And in engineering materials, we discuss today basic about stress and strain. In the mechanics, we have discussed stress, which is known as force per unit area, given by the formula sigma is equal to F upon A, where sigma is equal to stress applied or force applied. F is the force and A is the area of force application. And in this category, we have discussed strain. Strain is the amount of deformation experienced in the body in the direction of force. And we have put the relation between delta L upon L is equal to epsilon. Epsilon is equal to change in length upon original length. Strain is due to stress applied in the direction of change in length. Ratio of change in length to the original length is known as strain. And according to Hooke's law, it states that strain of the material is proportional to applied stress. Within elastic limit, stress is directly proportional to strain. And we have shown the graph stress-strain relationship for material under load. Stress and corresponding value of strain are plotted. And in the y-axis, we have plot stress, and in the x-axis, we have plot strain. So according to Hooke's law, there are two regions. One is elastic region, another is plastic region. In the elastic region, the Hooke's law is followed, and in the plastic region, there is upper yield point, and one other point C is lower yield point. एंड आपको बता दूं, जहाँ पे अपर यील्ड पॉइंट होता है उसके बाद मटेरियल में जो होते हैं क्रैक्स जनरेट होना शुरू हो जाते हैं, और मटेरियल क्या हो जाता है, एक वायर की तरह पतला होता जाता है. और जैसे ही हम फोर्स अप्लाई करते हैं, स्ट्रेस अप्लाई करते हैं, तो जो होता है ब्रेकिंग स्ट्रेस आता है, और एट द एंड फ्रैक्चर पॉइंट आता है. इस पूरे रीजन में मटेरियल क्या होता है, प्लास्टिक जैसा बिहेव करता है. तो इलास्टिक रीजन के बाद प्लास्टिक रीजन स्टार्ट होता है. सो आफ्टर दैट वी हैव डिस्कस सम प्रॉपर्टी स्ट्रेंथ. In the mechanics of material, strength of a material is its ability to withstand an applied load without failure or plastic deformation. The field of strength of material deal with the force and deformation that result from their acting on the material. A stronger material can withstand greater load. जो मटेरियल स्ट्रांग होता है वो ज़्यादा लोड को वेयर कर सकता है और उसकी स्ट्रेंथ ज़्यादा होती है. जो मटेरियल वीक होता है उसकी स्ट्रेंथ क्या होती है, कम होती है. स्ट्रेंथ मटेरियल टू मटेरियल वेरी करती है. There are some property like elasticity. It is the ability of a deformed material body to return to its original shape and size when the force causing the deformation are removed. A body with this ability is said to behave or respond elastically. Rubber and spring are the best example of ductile material, and elasticity is a tensile property. And another property which is plasticity. The plasticity is the property of a body to lose its property of elasticity. मतलब हमने पहले ही ग्राफ में बताया कि इलास्टिसिटी के बाद जो प्रॉपर्टी आती है वो होती है प्लास्टिसिटी. एंड एक्वायर अ परमानेंट डिफॉर्मेशन. प्लास्टिसिटी को हम परमानेंट डिफॉर्मेशन भी कह सकते हैं ऑन द रिमूवल ऑफ डिफॉर्मिंग फोर्स. प्लास्टिक डिफॉर्मेशन टेक प्लेस बियॉन्ड द इलास्टिक रेंज. जो प्लास्टिक डिफॉर्मेशन होता है वो इलास्टिक डिफॉर्मेशन के बाद आता है. इट इज द नेसेसरी फॉर फोर्जिंग एंड कोल्ड वर्किंग प्रोसेस. Plastic design of structure, lead and clay used as a plastic material. lead और clay को हम प्लास्टिक मटेरियल के रूप में यूज करते हैं. डक्टिलिटी, another property. डक्टिलिटी में क्या होता है, मटेरियल को पहले ही बच्चों ने सभी ने सुना है कि डक्टिलिटी क्या होती है। इट इज डिफाइंड बाय द डिग्री ऑफ विच मटेरियल कैन सस्टेन टेंसाइल strain before failure from a stress greater than the material stress. Material generally considered ductile if it is able to undergo significant plastic deformation before failure. Steel is the best ductile material, silver, copper, जिसके वायर बनाए जाते हैं, and aluminium, nickel, tin are the ductile materials. Gold is the mostly ductile material. And one other property is brittleness. Brittleness describes the property of material that fracture when subjected to stress but has a little tendency to deform before rupture. Brittle material are characterized by little deformation. इनमें क्या होता है, थोड़ा सा deformation होता है. Poor capacity to resist impact and vibration of load. High compressive strength, low tensile strength, glass and cast iron are the best example of brittle material. Another property is malleability. Malleability is a property of material. इसे हम कुट्यता भी कहते हैं और आघात वर्धनीयता भी कहते हैं. Malleability is a property of metal that define their ability to hammered, pressed, or rolled into thin sheets without breaking. It is a special case of ductility. Ductility का जो special case है वो malleability होता है, which permit the material to be flattened into thin sheet. यहाँ पे material को क्या है, पतली sheet में convert किया जाता है. Soft steel and wrought iron are malleable material. And another property is hardness. It is a very fundamental and very important property of material. Hardness of a material is defined as its ability to withstand localized permanent deformation, typically by indentation. अब हम क्या करते हैं, जब हार्डनेस चेक करते हैं तो उसमें मटेरियल पे क्या हम स्क्रैच बनाने की कोशिश करते हैं, तो वो नहीं हो पाता है. हम मटेरियल पर क्या करते हैं, रजिस्ट मटेरियल रेजिस्टेंस टू डिफॉर्मेशन ड्यू टू अदर एक्शन. मटेरियल पे हम कटिंग करते हैं, एवरेशन करते हैं, तो ये क्या है, उसका अपोज करता है. सो इट इज कॉल्ड फंडामेंटल प्रॉपर्टी ऑफ मटेरियल एंड क्लोजली रिलेटेड विद स्ट्रेंथ. किसी मटेरियल की स्ट्रेंथ ज्यादा होगी तो हार्डनेस भी ज्यादा होगी. किसी मटेरियल पर हम स्क्रैच नहीं बना सकते हैं, कटिंग नहीं कर सकते हैं, एवरेशन नहीं कर सकते हैं, तो उसका क्या करता है, मटेरियल अपोज करता है. तो हार्डनेस क्या है, फंडामेंटल प्रॉपर्टी है. Another property is creep. Creep is slow change. It is called progressive permanent deformation. The change in the dimension of material due to prolonged stress. लगातार stress दिया जाता है. Most common metal exhibit creep behavior. Creep may be defined as slow and progressive deformation of material with time. Time के respect में deformation होता है. So most under a constant stress. Part used in ice engine, turbine, boiler made by creep. And another property is fatigue. Material fatigue is a phenomena where structure fails when subjected to a cyclic load. यहाँ पे मटेरियल पर साइक्लिक लोड लगाया जाता है. दिस टाइप ऑफ स्ट्रक्चर डैमेज occurs when even when the experienced stress range is far below the statistical material strength. Fatigue is the most common source behind failure of mechanical structures. Some property coming under category of metallurgy, and by this process we have to make or manufacture our engineering material. Metallurgy is a part of material science and engineering that involve the study of physical and chemical behavior of metal. मेटलर्जी के द्वारा हम मटेरियल का फिजिकल और केमिकल बिहेवियर क्या करते हैं, डिस्कस करते हैं. इट इज अ साइंस that deal with the procedures used in extracting metal from their ores, purifying and alloying metals. metal को हम क्या करते हैं, प्यूरिफाई करते हैं. and creating useful object from metal. metal को हम different shape में बदलते हैं और useful object बनाते हैं. metallurgical engineering is based on the principle of science and engineering and may be divided into process metallurgy. metallurgy क्या है, इसे हम हिंदी में धातु प्रक्रम करते हैं और इसी के द्वारा हम धातुओं का निर्माण करते हैं. तो मेटलर्जी इंजीनियरिंग का एक बहुत इंपॉर्टेंट पार्ट है. सबसे पहले हम इसमें फिजिकल और केमिकल बिहेवियर की स्टडी करते हैं और इसमें मेटल को उसके ओर से एक्सट्रैक्ट करते हैं, प्यूरिफाई करते हैं और डिफरेंट ऑब्जेक्ट क्रिएट करते हैं। मेटलर्जिकल इंजीनियरिंग इज बेस्ड ऑन द प्रिंसिपल of science and engineering may be divided into process of metallurgy, which is concerned with extracting metal from their ores to make refined alloy, and physical metallurgy, which involve the shaping, alloying, heat treatment, joining process, and corrosion protection. Extraction of metal from its ore is the third and ultimate process in metallurgy. The extraction of metal and its isolation occur over few major steps. First one is concentration of ore. Second one is extraction of metal from concentrated ore. Third one is purification of metal. How is iron extracted from its ore? हम जानना चाहते हैं कि आयरन को उसके ओर से कैसे एक्सट्रैक्ट किया जाता है. इट्स a long process which began the concentration through clinical roasting. Concentration remove the water and other volatile impurities such as sulfur and carbonates. This concentrated ore is mixed with limestone, चूनापत्थर and coke and fed into blast furnace. Blast furnace जिसमें हम आयरन ओर को एक्सट्रैक्ट कर रहे हैं from the top. It is the blast furnace that extraction of iron occurs. The extraction of separating the useful components from waste material such as iron from its ore is a long and subdued process that help in slag. The biomaterial. Another material, biomaterial is a substance that has been engineered to interact the biological system for medical purpose, either in therapeutic treat, argument, repair and replace a tissue function of a body or a diagnostic one. As a science biomaterial about 50-year-old, the study of biomaterial is called बायोमटेरियल साइंस और बायोमटेरियल इंजीनियरिंग. बायोमटेरियल क्या है? जब हमारे बॉडी में कोई इंजरी हो जाती है, हमारे बॉडी में कोई पार्ट है जिसे हम क्या करते हैं, जैसे हार्ट में बाल्ब लगाया जाता है, ऑर्थोपेडिक डिवाइस लगाई जाती है, जिस तरह से बायोमटेरियल क्या करते हैं, उस बॉडी को चलाने के काम आते हैं. सेमीकंडक्टिंग मटेरियल रेंज प्राइस and availability from abundant silicon and expensive rare earth element, solar cell, IoT sensor, self driving car circuit, all material, all required semiconducting material to function. The modern world quite literally owed its existence to semiconductor and material used in their manufacture. As extension semiconductor material reach their physical limitations, new material poised to take their place. The market of these material coupled with new semiconductor application in changing manufacturing and material procurement throughout the industry. Refractory material. A refractory material or refractory is a material that resists decomposition by heat, pressure, chemical attack, retain strength, and from high temperature. Example of conducting refractory are silica, zirconia, whereas example of non-conducting refractory are silica and alumina, including refractory calcium silicate material, kaolin, zirconia. Insulating refractory are used to reduce rate of heat loss. ये रिफ्रैक्टिव मटेरियल क्या होते हैं? उच्च ताप सहन करने वाली धातुएं होते हैं जो प्रेशर को, हीट को, केमिकल अटैक को अपने में क्या कर देते हैं, बियर कर लेते हैं और मटेरियल को लॉस होने से बचाते हैं. कंपोजिट मटेरियल. कंपोजिट मटेरियल इज अ कॉम्बिनेशन ऑफ टू मटेरियल विद डिफरेंट फिजिकल एंड केमिकल प्रॉपर्टी. यहाँ पे हम क्या करते हैं, दो मटेरियल का कॉम्बिनेशन लेते हैं जिनकी फिजिकल और केमिकल प्रॉपर्टी क्या होती है, डिफरेंट होती है. when they are combined they create a material which is specialized. ऐसा मटेरियल बनाते हैं जिसकी प्रॉपर्टी क्या होती है, स्पेशलाइज्ड होती है, डिफरेंट होती है. to do a certain job. For instance, to become stronger, lighter, and resistance to electricity. They can also improve strength and stiffness. The composite material include reinforced concrete, masonry, composite wood such as plywood, ceramic material is a inorganic, non-metallic, often crystalline oxide, nitride, carbide. इसमें मेटल के ऑक्साइड नाइट्राइड कार्बाइड टाइप के मटेरियल आते हैं. Some elements such as carbon, silicon may be considered as ceramic. Ceramic material are brittle, hard, strong in compression, and weak in shearing and tension. Ceramic are more than pottery and a disc, clay, brick, glass, cement. Probably the best known example, ceramic material are used in electronics because depending on their composition, they may be semiconducting, superconducting, ferroelectric or an insulator. So ceramic material को घर में हम पॉट के रूप में यूज करते हैं, घर में हम कई सारी चीजें चीनी मिट्टी की क्ले की यूज करते हैं. Modern material refer to the material with property that traditional material do not possess. The chemical or physical property of these material can be changed by external factor like temperature, light, electric charge, so as to meet a specific requirement in modern technology. The knowledge of materials characteristic allow the designer not only to make the best material selection as a function of its application in the given product, but also to overcome its limit and constraints in the design path. For material and transformations, technology become variable to the creation process. Next. Ideal material choice for your design give you a competitive edge by affecting invariably improving the factors such as function, mechanical property, quality, manufacturability, endurance and performance, environmental impact, and cost of your mechanical product component design. Ideal material choice for your design give you a competitive edge by affecting and invariably improving the factors such as function, mechanical property, quality, manufacturability, endurance and performance, environmental impact, and the cost of your mechanical product component design. Example of material is the fabric from which something is made. An example of material is wood used to build something. Technological property, there are few machinability. It is defined as easy with the given material can be cut permitting the removal of material with a satisfactory finish as lower cost. Weldability, castability, formability, machine malleability. One we can discuss weldability, also known as join ability. It is called joining ability of a material refer to its ability to be welded. Many metal and thermoplastic can be welded, but some are easier to weld than others. See, rheological weldability. Weldability is often hard to define quantitatively, so most standard definite qualitatively the effect on weldability of element like chromium, vanadium, while not a great as carbon, most significant that of copper and nickel. For example, as the equivalent carbon content rise, the weldability of the alloy decreases. Castability is the easy of forming a quality casting. A very castable part design is easily developed, incur minimum tooling costs, require minimal energy, and has few rejection. Castability can refer a part design or a material property. Mold material should be low thermal conductivity and fine surface. Higher the thermal conductivity of mold and rougher the surface, the lower will be the castability. Dry sand mold and high castability than green sand mold. Thank you.